Hi, Alex here. Sitting here with Jeff Darnton today. We're going to talk about caching and specifically API caching. This has been part of a series that we've been doing over the last few weeks, talking about different things we could do to improve our web performance. In the last call we had, we specifically found out that like API caching was this kind of interesting thread to pull on and something that people might not be doing as much of today as they really could be doing. So, Jeff, like, what is API caching to you, and why does it matter?
Yeah, I mean, again, we APIs are just another type of content. So caching is caching to some extent, right? It's wherever the source of that information is. Instead of retrieving that from there, we're going to retrieve it from somewhere closer, and ideally that makes it more performant and ideally less costly in order to serve that response, as well as it helps us scale to support higher levels of traffic. So API responses are just one type of content that we can cache. But usually folks think it's not cacheable because it's very dynamic. It's sometimes very personalized, and it can be structured or unstructured depending on whether you're using kind of a traditional REST interface or GraphQL. So there's lots of challenges around it. But the reason why we're talking about it is it's just as important, if not sometimes more important, to the end user experience and the performance of that website or that mobile application, because it's so much of the content being rendered there or the information being loaded comes from an API. We have to cache it. It has to be part of our performance journey. We really need to think about it in order to get that full picture and be able to offer that best performance.
Okay, so you did mention a few things there. You mentioned GraphQL and you mentioned REST. What is kind of the difference there, and like what are some of those challenges that are unique to each of those?
Yeah, so REST would be, more of a traditional API. This is where we structure specific endpoints, and it's a very structured set of calls where we're either, inputting data, changing data, or retrieving data. But it's very specific formats for input and very specific formats for output, and very structured in what the information is. And that can be really, really good depending on what your data source is. If your data is really structured and your application is really structured, that works great. And since it's so structured, we can sometimes get more effective at caching it because we know exactly what it's going to be and we know what the variations are going to be and whether we've got to worry about different languages and personalized for logged in or not. So that's great. But what if your data is very unstructured, or if your application needs to be very dynamic? That's where GraphQL comes in. And so it allows us to establish a schema on the server side, and it allows the clients to interact with that schema however they would like. So you think about, like, let's get information about a user. In a REST scenario, you would make a call to the /userinfo endpoint or
Uh-huh.
something like that. And it would give you a name and an address and an email and a phone number and all this stuff, all that information. But what if I only want the phone number?
Uh-huh.
Instead of having to define another phone number endpoint in the REST world,
Uh-huh.
in the GraphQL world, I could just say, hey, for this user, give me their phone number. And GraphQL is able to respond in a way that only gives me the data that I'm looking for because it's schema aware of how all of that data is stored. So again, I know that a person has these different attributes around it, and then I can ask for certain attributes of that person, or I could ask for all of the attributes of that person. Or if there were a certain number of people or a certain number of, maybe items is a better SKUs. It's give me the information about this SKU, the price of this SKU, and I could just get that rather than say list all SKUs, list this SKU, then extract the price. It could be much more efficient and effective with a single GraphQL call than two or three different REST calls that might include lots and lots of information.
So then it requires less processing on the server side, but also it makes it easier for the client since they can get exactly what they're looking for.
Exactly, less data
Right.
down, right? So again,
Yeah.
particularly on mobile application, maybe you've got a very limited 4G connection or something like that. The less bytes we have to send down, the faster we can make that response, and we don't have to parse all of that data to just get the one piece of information.
So within the Harperverse here, like what are the kind of the solutions that we're offering? You mentioned Graph, you mentioned REST. How do we go about approaching and kind of solving for these caching scenarios?
Yeah, and we talked about kind of cache strategies before, active and passive, whether we're
Uh-huh.
pushing stuff into cache or pulling out of it. One of the unique things about us, right, is that we've got that data store behind all of this, right? So we're not just a cache, we can also be the source of truth. So whatever your data is, if you want to access that via GraphQL, you could use us as the GraphQL cache so that we could cache those responses, but you could actually push the database forward to us and actually use us as the source to be that API endpoint. So most folks will have an API gateway that would then have a cache layer that would then have the database. We could be all three, and you can push that out to the edge because we can respond with the GraphQL component. So it's a really unique way to think about API caching rather than just how do I cache the response? It's how do I actually move the full API endpoint up to the edge or closer to wherever I want those end users to be. And because Harper has all of that, it's really easy to go about getting that done. So and again, that holds true on the REST side as well, because we can also be that RESTful API endpoint, whether that's something that you can use built in from our operations API, or if you want to build your own custom application as a Harper component, that can also serve as the custom API endpoint there as well. So that flexibility to approach this from, instead of just a kind of a passive cache and how do I define the cache keys and figure out the TTLs and all of that, it's really picking up the whole API application layer and putting it out there that's coupled with that caching.
Okay. So you did mention edge there a little bit. I kind of want to dig in on that. So it seems like when we're talking about caching, performance is important, which means that we need to be closer to the user, and then edge is important. As that data is coming in, how important is it for those caching locations to communicate with each other so that if it's cached in one location, that it does show up in the other, and it's not waiting for a secondary call to make that happen?
Right. Yeah. And depending on the application, it could be critical. Right. And so you'll generally hear these distributed systems talked about, whether they're eventually consistent or not. And Harper is an eventually consistent caching system, or excuse me, replication system, which means that when you write on one node, it's not immediately, it doesn't lock until that write is written to the entire cluster. So whatever that data is that you're using, you need to account for the fact that it's eventually consistent. Now, in some systems, that might be seconds or minutes. Generally, what we see is something under 100 milliseconds globally for that eventual consistency, for that replication to occur between different nodes, depending on where they are and how much data is being transferred. But so even in that, kind of certain applications aren't super good, like trading stocks. Harper wouldn't be a great thing to be the ledger for trading stocks. But for stock ticker information or publishing information about stocks or the record of what did happen and people want to read that, fantastic way for Harper to be the API endpoint to receive that information, publish that information, cache that information, because we could do so in a distributed manner and very, very fast. So yeah, that replication time is important. And that replication of the cache is what we're talking about here. So if I get a hit in Germany for a particular record, and now I'm getting that same request in the East Coast of the United States, those might be two different nodes in a cluster responding, but because we're replicating that cache across them, or you don't have to, but because we could replicate that, you would be able to serve that content from cache over there as well, and you get that same cache response.
That makes sense. Very interesting stuff here on API caching. Anything else to leave us with before we head out?
I think the biggest thing is everybody focuses on caching and we think of images and video because that's content and it's the most amount of bytes, and that's sometimes the easiest place to go. So when we talk caching, that's what we think. Don't forget about API caching. So much of your application depends on API responses, and they're more cacheable than you think, even for a very, very short period of time. Seconds matter here. If you're only updating your inventory every 20 seconds, you can cache inventory response calls, and that's an eye-opening scenario. So dig in, figure out where you can cache, challenge the assumption that APIs are uncacheable, and think about creative ways to approach this. Instead of just caching, how can I move my API layer further closer to the edge with something like that?
Awesome. A lot of great points on API caching, Jeff. Thank you so much, and we'll catch you next time.
Thanks, Aleks.